In this lesson, we will find the inverse of matrices, invertible matrices. An n by n matrix A is invertible if there exists a matrix A inverse such that A inverse times A equals A times A inverse equals the n by n identity matrix. If A is invertible, then A inverse is unique. And note that not all matrices are invertible. Finding the inverse of a matrix. If we start with an n by n matrix A and an n by n identity matrix and multiply A inverse by each of these, A times A inverse will be equal to the identity matrix, and the identity matrix times A inverse will be equal to A inverse. This leads to our technique for finding inverse matrices. We create an augmented matrix with A to the left of the vertical line and the identity matrix to the right of the vertical line. After transforming the matrix into reduced row echelon form, the identity matrix will be on the left and A inverse will be on the right of the vertical line. Let's find the inverse of the matrix M, which is equal to 2, 5 in the first row and 1, 3 in the second row of our 2 by 2 matrix. We'll start by creating an augmented matrix with M to the left of the vertical line and the 2 by 2 identity matrix to the right of the vertical line, and we will transform this matrix into reduced row echelon form, starting with, I would like to have a 1 in row 1 column 1. I can do that by swapping rows. So now row 1 is 1, 3, 0, 1, row 2 is 2, 5, 1, 0. I will next try to get a 0 in row 2 column 1. I can do that by multiplying row 1 by a negative 2, adding the result to row 2. Now row 1 is 1, 3, 0, 1, and row 2 is 0, negative 1, 1, negative 2. I will next change the negative 1 into a 1 by multiplying row 2 by negative 1. Now row 2 is 0, 1, negative 1, 2. The only thing holding us back from having a matrix in reduced row echelon form is this 3 in row 1 column 2. To turn that into a 0, I will multiply row 2 by negative 3, add the result to row 1, and place the result of that operation into row 1. So now row 1 will be equal to 1, 0, 3, negative 5. Row 2 is 0, 1, negative 1, 2. The matrix is in reduced row echelon form with the identity matrix to the left side of the vertical bar and M inverse to the right side of the vertical bar. So M inverse is equal to 3, negative 5 in the first row, negative 1, 2 in the second row. I can show that M inverse is the inverse by taking M times M inverse. M was the matrix 2, 5, 1, 3. And so if we multiply these two matrices together, actually in either order, we will end up with a 2 by 2 identity matrix 1, 0, 0, 1. Let's find the inverse of the 3 by 3 matrix D, which has 1, negative 1, 1 in the first row, 0, 2, negative 1 in the second row, and 2, 3, 0 in the third row. We'll start by creating an augmented matrix with D on the left and the 3 by 3 identity matrix on the right of the vertical line. The order that we will need to follow here to change this large augmented matrix into reduced row echelon form will be to first get a 1 in row 1 column 1 followed by zeros below, then a 1 in row 2 column 2 followed by a 0 below, then a 1 in row 3 column 3. We will next move up to getting a 0 in row 2 column 3, then a 0 in row 1 column 2, and a 0 in row 1 column 3. After we have worked through the necessary steps to achieve that goal, we will have the identity matrix on the left side of the vertical bar, and to the right of the vertical bar will be D inverse, which is the 3 by 3 matrix with row 1 of 3, 3, negative 1, row 2 of negative 2, negative 2, 1, and row 3 of negative 4, negative 5, 2. Try on your own. Find the inverse of the matrix C, which is equal to 2, 1 in the first row, 3, 1 in the second row, using the method from this lesson.